The National Electrical Code, or NEC, is a regionally adoptable standard for the safe installation of electrical wiring and equipment in the United States. It is part of the National Fire Codes series published by the National Fire Protection Association, or NFPA. While the NEC is not itself a federal law, it is commonly adopted by states and municipalities in an effort to standardize their enforcement of safe electrical practices. Many jurisdictions require electricians to be licensed, and part of maintaining that license often involves continuing education related to the NEC. The NEC is updated every 3 years. It's important to stay current with the latest edition because electrical codes can change significantly, impacting how electrical work is performed and inspected. These updates address new technologies, safety concerns, and evolving best practices. Online resources can be a valuable tool for NEC training and license renewal. These resources often provide interactive modules, practice exams, and explanations of complex code requirements. They can also be tailored to specific regions, reflecting local interpretations and enforcement practices. When evaluating online NEC training materials, consider the following factors. Firstly, the provider's credentials and experience. Look for organizations with a proven track record in electrical education and a deep understanding of the NEC. Secondly, the content's accuracy and relevance. Ensure that the materials are up to date with the latest NEC edition and that they cover the specific topics relevant to your license renewal requirements. Thirdly, the learning format and features. Choose resources that offer a variety of learning methods such as videos, simulations, and interactive exercises to cater to different learning styles. Let's consider some key areas typically covered in NEC training. Firstly, general requirements for electrical installations, including wiring methods, overcurrent protection, grounding, and bonding. Secondly, specific requirements for different types of occupancies such as residential, commercial, and industrial buildings. Thirdly, requirements for specialized equipment and systems such as fire alarm systems, emergency power systems, and renewable energy systems. Fourthly, safety requirements for working with electricity, including lockout/tagout procedures, personal protective equipment, and safe work practices. Understanding wiring methods is crucial. The NEC specifies acceptable wiring methods for various applications, considering factors like voltage, amperage, environment, and built-in construction. Common wiring methods include, firstly, non-metallic sheaths cable, or NM cable, commonly used in residential wiring for branch circuits. Secondly, electrical metallic tubing, or IMT, a thin-walled conduit often used in commercial and industrial applications. Thirdly, rigid metal conduit, or RMC, a heavy-walled conduit used in harsh environments or where physical protection is required. Fourthly, flexible metal conduit, or FMC, a flexible conduit used for connecting equipment to electrical boxes. Fifthly, cable trays, used to support and route cables in industrial and commercial settings. Overcurrent protection is another vital area. Overcurrent protective devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating and fires. The NEC specifies the type and size of overcurrent protection required for different circuits, based on the ampacity of the conductors and the rating of the connected equipment. It's essential to understand how to properly select and install overcurrent protection devices to ensure the safety of electrical systems. Grounding and bonding are critical for preventing electrical shock hazards and ensuring the proper operation of electrical equipment. Grounding provides a low impedance path for fault current to return to the source, tripping the overcurrent protection device and energizing the circuit. Bonding connects all non-current carrying metal parts of an electrical system to create an electrically conductive path, minimizing the potential for voltage differences and reducing the risk of shock. The NEC has detailed requirements for grounding and bonding, covering everything from grounding electrode systems to equipment, grounding conductors. The NEC addresses specific requirements for different types of occupancies, recognizing that the electrical needs and hazards vary depending on the use of the building. For example, residential occupancies have requirements for ground fault circuit interrupters, or GFCIs, in bathrooms, kitchens, and outdoor areas to protect against electrical shock. Commercial occupancies often have requirements for emergency lighting and exit signs to ensure safe evacuation in case of a power outage. Industrial occupancies may have requirements for hazardous location wiring and equipment to prevent explosions and fires. Specialized equipment and systems also have specific requirements in the NEC. Fire alarm systems must be installed and maintained according to the NEC and other applicable standards to ensure reliable operation in the event of a fire. Emergency power systems, such as generators and uninterruptible power supplies, or UPSs, must be designed and installed to provide backup power to critical loads during a power outage. Renewable energy systems, such as solar photovoltaic, or PV, systems and wind turbines, must be installed according to the NEC and other applicable standards to ensure safety and proper operation. Safety requirements for working with electricity are paramount. The NEC emphasizes the importance of lockout/tagout procedures to prevent accidental energization of electrical equipment during maintenance or repair. Lockout/tagout involves disconnecting the power source, locking the disconnect switch in the off position, and tagging it with a warning label. Personal protective equipment, or PPE, such as rubber gloves, safety glasses, and insulated tools, is essential for protecting workers from electrical shock and other hazards. Safe work practices, such as maintaining a safe distance from energized equipment and using appropriate testing equipment, are crucial for preventing accidents. One aspect that is often overlooked is the proper use of testing equipment. Multimeters, for example, are indispensable tools for electricians. They can measure voltage, amperage, resistance, and continuity, allowing electricians to troubleshoot circuits, verify power sources, and check for ground faults. It is important to use a multimeter that is rated for the voltage and current levels being measured and to follow the manufacturer's instructions carefully. Clamp-on ammeters are used to measure current without having to disconnect the circuit. These meters are particularly useful for measuring high currents or for measuring current in conductors that are difficult to access. Insulation resistance testers, also known as megometers or megas, are used to measure the resistance of insulation. These testers apply a high voltage to the insulation and measure the leakage current. A low insulation resistance reading indicates that the insulation is damaged or deteriorated and needs to be replaced. Ground fault circuit interrupter, or GFCI, testers are used to verify that GFCIs are functioning properly. These testers simulate a ground fault and should cause the GFCI to trip. Understanding the NEC also involves knowing how to navigate the code book itself. The NEC is organized into chapters, articles, and sections. Each section contains specific requirements for electrical installations. The NEC also includes tables and examples to help clarify the code requirements. It's important to become familiar with the organization of the NEC and to know how to find the information you need. Let's delve further into specific NEC articles. Article 210 covers branch circuits, which are the circuits that supply power to outlets, lighting, and appliances. Article 215 covers feeders, which are the circuits that carry power from the service equipment to the branch circuits. Article 220 covers branch circuit, feeder, and service calculations, which are used to determine the size of conductors and overcurrent protection devices. Article 230 covers services, which are the conductors and equipment that bring power from the utility company to the building. Article 250 covers grounding and bonding, which are essential for electrical safety. Article 300 covers general requirements for wiring methods and materials. Article 310 covers conductors for general wiring, including ampacity tables and dating factors. Article 400 covers flexible cords and cables, which are used for connecting portable appliances and equipment. Article 430 covers motors, motor circuits, and controllers, which are used for powering industrial equipment. Article 440 covers air conditioning and refrigeration equipment, which have specific electrical requirements. Article 500 through 516 covers hazardous locations, which require special wiring and equipment to prevent explosions and fires. Calculations are a vital part of NEC compliance. Calculating the correct conductor size for a given load is essential for preventing overheating and voltage drop. The NEC provides ampacity tables that list the allowable ampacity of different types of conductors based on their size, insulation, and temperature rating. Directing factors must be applied when conductors are installed in raceways or cables with multiple conductors to account for the increased heat generated by the conductors. Calculating the correct overcurrent protection device size is also crucial. The overcurrent protection device must be sized to protect the conductors from overcurrent without causing nuisance tripping. The NEC provides rules for selecting the appropriate overcurrent protection device based on the conductor ampacity and the type of load being served. Calculating voltage drop is important for ensuring that the voltage at the load is within acceptable limits. Excessive voltage drop can cause equipment to malfunction or fail. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Understanding grounding and bonding is also essential. Grounding electrode systems must be installed to provide a low impedance path for fault current to return to the source. Common grounding electrodes include ground rods, ground plates, and metal water pipes. Equipment grounding conductors must be installed to connect all non-current carrying metal parts of an electrical system to the grounding electrode system. Bonding jumpers must be used to bond together different metal parts of an electrical system to create an electrically conductive path. The NEC also covers requirements for specific types of equipment and systems. Generators must be installed according to the NEC and other applicable standards to ensure safe and reliable operation. Transfer switches must be used to switch between the utility power source and the generator power source. Uninterruptible power supplies, or UPSs, must be installed to provide backup power to critical loads during a power outage. Surge protective devices, or SPDs, must be installed to protect electrical equipment from voltage surges. Staying current with NEC updates is essential for all electricians and electrical contractors. The NEC is updated every 3 years, and each new edition includes changes that can affect how electrical work is performed. It's important to attend training courses, read industry publications, and consult with electrical inspectors to stay up to date on the latest code requirements. Beyond the specific articles and sections of the NEC, it is crucial to understand the underlying principles that guide the code. The NEC is fundamentally a safety document. Its primary goal is to protect people and property from the hazards of electricity. It achieves this through a combination of prescriptive and performance-based requirements. Prescriptive requirements specify exactly how electrical installations must be done. Performance-based requirements set a performance goal, but allow flexibility in how that goal is achieved. Understanding these principles can help electricians make informed decisions when applying the NEC in real-world situations. The NEC also reflects a consensus-based approach. It is developed by a committee of experts from various segments of the electrical industry, including electrical inspectors, engineers, contractors, manufacturers, and insurance representatives. This ensures that the NEC is practical, technically sound, and reflects the needs of all stakeholders. The NEC is not intended to be a design manual. It provides minimum requirements for electrical safety. Electrical designers may need to exceed these requirements in order to meet the specific needs of a particular project. The NEC also does not cover all aspects of electrical design. Electrical designers must also consult other relevant standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. When using the NEC, it's important to understand the definitions of key terms. The NEC includes a chapter of definitions that defines many of the terms used throughout the code. Understanding these definitions is essential for interpreting the code correctly. Some important definitions include ampacity, which is the current carrying capacity of a conductor in amps. Bonding, which is the permanent joining of metallic parts to form an electrically conductive path. Branch circuit, which is the circuit conductors between the final overcurrent device protecting the circuit and the outlet. Conductor, which is a material, usually a wire or cable, suitable for carrying electric current. Ground, which is a conducting connection, whether intentional or accidental, between an electrical circuit or equipment and the earth. Ground fault, which is an unintentional connection between an energized conductor and ground. Overcurrent, which is any current in excess of the rated current of equipment or the ampacity of a conductor. Raceway, which is an enclosed channel designed expressly for holding wires, cables, or bus bars. The NEC also includes annexes, which provide additional information and guidance. Annexes are not part of the enforceable requirements of the NEC, but they can be helpful for understanding the code and applying it in practice. Annex A provides product safety standards. Annex B provides application examples for ampacity calculation. Annex C provides conduit and tube fill tables. Annex D provides examples for calculating branch circuit, feeder, and service loads. Annex E provides examples for calculating fault current. In addition to the NEC, there are the relevant codes and standards that may apply to electrical installations. The International Building Code, or IC, includes requirements for fire safety, structural safety, and accessibility. The International Mechanical Code, or IMC, includes requirements for mechanical systems such as heating, ventilation, and air conditioning. The National Fire Alarm and Signaling Code, or NFPA 72, includes requirements for fire alarm systems. The Life Safety Code, or NFPA 101, includes requirements for life safety in buildings. Electrical inspections are an important part of ensuring that electrical installations comply with the NEC. Electrical inspectors review electrical plans, inspect electrical installations, and issue permits and approvals. The electrical inspections help to ensure that electrical work is done safely and correctly. When preparing for an electrical inspection, it's important to have all the necessary documentation, including electrical plans, permits, and product specifications. It's also important to make sure that the electrical installation is complete and ready for inspection. The electrical inspector will typically check for compliance with the NEC as well as any other applicable codes and standards. The NEC is a complex and comprehensive document, but it is essential for ensuring the safety of electrical installations. By understanding the NEC and following its requirements, electricians and electrical contractors can help to protect people and property from the hazards of electricity. Continuing education and training are crucial for staying up to date on the latest code requirements and best practices. Online resources can be a valuable tool for achieving these goals. And remember, always consult with a qualified electrical inspector or engineer if you have any questions about the NEC or electrical installations.